suggestions about what we want to use for U substitution? Just throw something out there. Yeah? 1 minus sine squared. Okay, that's pretty complex for you. Because, okay, go ahead and take the derivative of it. Do we have all that left over if we're going to use this for U? All we got is cosine of x. So
I'm just trying to use cosine.
you just want to use cosine of x?
Sure.
Okay, again, you just got to try something. So if we use cosine of x, du dx is going to be negative sine of x. How are we going to get sine of x to be squared? Square du?
We put 2 du's in there.
We can square just pieces. We can square. We want du squared.
Can we add 2 of you? Can we add 2
Well,
of
have you ever seen that du squared? No. But we don't. We can't do that. Okay. All right. What's our next choice? No. I don't want you.
That's what I would do. The 1 and the sine squared? Yeah.
Okay. Come on, give me something else. One more thing. Come on. Jenna. No, that's not. No. I know. Yeah. Come on. No. There's no such thing. Emily, help me out. Come on. U equals. Her face does not look like she was out there. Christine. Come on, just throw something out there. We already tried that.
Okay.
I mean, that's not going to be any better than this. You're getting closer then, because see, du is still going to be 1. No. Oh my goodness. Just throw it out there, man. We throw it out there and you're like, nah, that's it. No. There's no nice square. No. You have supposed to throw stuff out. I said you squared earlier and you were like, no. You squared is not what we need. So. No, but you're going to end up there. Yeah, just throw it out. Just call it out. Outside of X. Okay. Do we have that? Yes. Okay, so here we go. Now we have du for cosine dx. What else is left?
1 minus u squared.
All right. Now, you got it. Finally. Fourth try. Okay? That's all right. Okay.
Really hard.
This is the anti-derivative. We need to find the antiderivative. Let's see. Megan Cook, give me the antiderivative. No X. Well, do you see one? Plus, this is the antiderivative with the u. We're not going to suddenly put our X back in. Now, we got our antiderivative. We are not done because we made up u. So we put it. What's it? Okay. Sine of x goes back in for u. Sine cubed of x is how we write that, plus c. There's your answer. Okay? Okay? So, point being, I can give you a tip, but sometimes you have to try out that anymore. Let's try something else, okay? Here's my tip of the day. When you have, everybody ready? My tip of the day. When you have a single, that needs to go with when you're doing cosine and sine, your singles need to go, one single, needs to go with the du, okay? And we can make whatever we need to make. If you have to use the chain rule for u, you're probably not using the correct u. You can probably make a simpler u. This would be a chain rule, this would be a chain rule. This just doesn't work because we don't have sine squared showing up, okay? I grabbed a single sign because I knew I could make u squared, and I knew I could do 1 minus u squared. I could find the antiderivative of it. Okay, so let's try this one. All right, first thing we're going to do is separate the 3 signs into squares. We'll have a leftover, and all right. So if you have more than 2, separate it into 2s, because this is 3, remember? Because we can swap that piece out. Now the single one needs to be saved for du. So I'm just going to separate. I got this. The single one is going to be your sine of x. So if that's in my du, what's going to be my u more than likely? Cosine. Very good. Okay. Sine of x dx will be taken care of right there. All right, so I'm still going to have, I can put, okay, that's not a problem, right? But thank you, Megan, good work. All right, I have my u squared right here. The derivative of cosine is negative sine. All right. This is du, correct? Ish with the green. All right, what am I going to do with that sine squared? It's 1 minus cosine squared. So it's really 1 minus u squared. Okay? Now that looks kind of complex, but everything's in terms of u, so it's all manageable. Did I lose anybody? Now, sometimes you'll substitute the wrong one in, so that's why I kind of waited to substitute that identity until I knew what my u was going to be. And then you're not doing it and then do it over. All right, so how shall I find an antiderivative of 1 minus u squared times u squared? Stick you first. All right, so what is that, Hannah?
U squared minus.
Okay. That's an easy antiderivative. What is it, Kaylin? Very good. Okay. So that negative's out there. You might want to distribute that, and then you don't have the need for so many parentheses. What's the last thing I need to do, Kat? Cosine of x. So cosine of x cubed looks like that. Remember, that's cosine x cubed. That's how you write it. Make that a plus, right? Cosine to the 5th x over 5 plus c. C is a constant. We don't know that it's positive or negative. So we don't have to mess with it.
So is it incorrect if you would have put minus c? Or necessarily?
No, I don't think you could. It's distributed from here. Okay, any other questions? It's ugly. This is your last integration method. You don't have, it doesn't show up very often, but when you got 10 problems and it shows up once, you gotta know how to do it, right? All right. Any questions? All right, let's do the next one. You want to try by yourself? This is a definite interval.
That's different.
Not really. Same. We're still going to start out with doubling them up. Okay. Yes, you can. We change it to an it. By it, you mean the squared, okay? You're going to probably change that to 1 minus cosine again. Okay, remember they both have to show up. So if they're not there, you know the swap is going to be there. The single needs to stay. So what's my u probably going to be, Christine? In order, go ahead. Cosine of x, good. Because that'll make du dx negative sine of x, which we can work with the, we can work with the negative sign to give us sine x dx. Sure? All right. Now, so what do we have in under our integration with our integration? What do we have? Instead of 1 minus cosine squared x, Lizzie? And do you have anything else? Negative outside. Anything else? Our limits, what are they? So they're u of 0 and u of pi. We have to change those. Okay. And we all forgot to change them.
Wow, good one, myself. I had to congratulate myself earlier for doing good work.
All right. So let me change this. Move this over here. Did we use anybody on the integration? We haven't done the antiderivative yet. All right. U of 0, what is that? U of 0 is cosine of 0. That's definitely 1. U of pi is the cosine of pi. That is definitely negative 1. So now we have this one here. 1 minus u squared du. All right. On definite integrals, I'm ready for an antiderivative. It's my antiderivative, Claire.
U minus u cubed over 3.
Right. Now, I do not have to put my x's back on a definite integral. I just do my u's all the way to the end now. Okay? All right. So I'm going to plug in a 1 first. Emily, what am I going to get?
Did you flip the 1?
Yeah.
Please flip them. Yeah, you're paying on negative 1. Yeah, because pi.
Okay. Thank you. All right.
It's okay that you did that.
Do you want to flip them?
Yeah, you also lost your negative. Yeah, it's okay that you did that. You got rid of your negative.
Okay.
No, don't do that. That increases.
So am I plugging in a negative one or what?
Okay. Back up. U of 0 was 1. U of pi was negative 1. This negative is still here. If I don't want to deal with that negative, would it make more sense to switch these around and now the negative's gone, right? Makes more sense to me. I'm doing it. Okay, so we're plugging in a 1. Emily? Okay. And we're plugging in a negative 1. Kathleen? Negative 1 third. Okay. All right. You don't have to group them accordingly if you want. All right. Yes? Pat? Kathleen, did you have a question? No. Okay. All right, I'm just going to get rid of my parentheses first since I got fractions on both of them. So what's this? Plus 1 minus a third when I get rid of my parentheses. 1 plus 1 is, and minus 1/3 minus 1/3 is minus 2/3. What's 2 minus 2/3? One and one third, or thirds, either one.
Would you not do that one thing when it's a big number, or one thing and one positive?
You could have, I guess. We should have done it way back here if we were gonna do it, but it's even. So it wouldn't really help us then. Does everybody see what Megan's saying? The symmetry thing, you do have the -1 to 1 here. So we could have checked to see that there was even or odd. It was even. So we could have then, it would have switched it to this. Or even that one, honestly. Okay, even isn't really that helpful. Okay, good question though, Megan. Anybody get hung up on this? Just the big thing is don't put your X back in on definite intervals. I see people putting back in there just making more work for themselves. You figured this out, you don't have to mess with X's anymore. You've accommodated the, right? Alrighty. Let's try another one. Oh, look at those cute little guys.
Wow, so diverse.
All right, I'm going to send you the handout. I didn't. When did I send you that? Oh, wow. Thank you. Yes.